Welcome to HeartBeat, a heart rate and blood level monitor built with the Particle 2 board, offering a compact and connected solution for real-time health tracking. Using compatible biometric sensors, this device can detect pulse reg signals, estimate blood oxygen level, and transmit this data through the Particle 2 board built in the in-cloud connectivity. Let me run you through the website. On the front page, and here is the reference page where we put on all the libraries we used. Notably charts.js, node.js, OLlama for our RESTful API, and our LLM. Then we have the About Us, where it displays the team members of the group. Jason White handling the back end, Jesse Codolese handling the embedded system, and Mohammed Kappa, who focused on the front end. Let me run you right through. First, you got to sign in, but first you have to create an account. With a password, and you have to use the Particle 2 board's serial number as the device ID. And after signing up, it will direct you to the login page where, again, and insert the password. Here we go. Now we're on the heart date data page. What you can see right here, you could device configure if you want to change the Particle 2 board by using a different serial number. We have the change password screen right here. Since you're already logged in, you just have to put in your current password, confirm it, and put in a new password if you hope to change your password at some point. And then when you click on devices, you are led to here with some already, because we have on the MongoDB, the device information. Throughout, you could select different days, depending on if there's information on there. On the left screen, it will show you the weekly, the average, minimum, and maximum your heart rate has been for the past 7 days. And on the bottom, it will show you the minimum and maximum your heart rate has been and the blood oxygen level. You could also display in mobile view, as you can see. And also leading us to the left towards the end of this project, the chat box, where you can ask important questions like, how is my heart health? And it will give you back a AI response for here based on your heart monitor data. Your heart health appears to be stable, heart rate of 90 and blood oxygen of 94 degrees, 94%. Anyways, as you can see, thank you for viewing our website. Log out and go. Hello, this is Mohammed Kappa. I was the front-end engineer on our 413 project, HeartBeat. Let me run you right through. I was pretty much responsible for the public folder. As you can see, organized. This is where we put in all our images that we use for references and also just design aspects of the project. Here are the libraries that I predominantly used. I used charts.js to formulate the charts using the data that we would get from the MongoDB website. And as I also used jQuery as a way to simplify a bunch of actions instead of just doing raw JavaScript code. Here are some of the about HTML pages. There's around 7 pages in total. The change password page, chat page that was worked on by the backend engineer actually, heart data page, heart graph, index where we put in the front page, the login, references, and sign up. Now on to the more robust part of the project. These are the JavaScript files we used for each page. The change password.js folder was used um, as a connection using AJAX request to the back end to change the password. If done correctly, it would just take you to the heartdata.html page, but would also show you a console error if you didn't successfully change the password. As we can see, this was the Olama LLM JavaScript page, which connected to the OLLM on one of our computers so that we could have an AI on the system, also using an AJAX request. Here was the daily.js folder, which would get the data that we used for the graph and the min and max for each and every day. This file would be called every time the initialized date was changed, depending on what date we picked on the calendar. This was the device page. We use this to change the device depending on if we wanted to have a different device on at the time. This is where we rendered our graph and got the data from the daily.js file and put it on here. And here are the labels, the data, and the timestamps, depending on what we have. Login and logout, both same AJAX requests practically, but the login request did generate us a token that we'll see right here, which allowed the user to stay logged in, even so he didn't have to sign in every single time. The web design page was mostly just working on the design aspects, just fading in and fading out animation stuff to make the page more dynamic, as well as just more practicality. And then finally, the weekly.js file, which was just responsible for doing a rate AJAX request to find the weekly data and the min and max and average heart rate, and it would get these and then would use the .text jQuery line to send out the data and display it onto the graph page. As we can see, this is where we run it locally. This is where we run it locally, and we could see that right here, depending in incoming login request, it would show and compare the passwords. It would generate the authentication token. Here also, when you click on to go to the graph page, it would show that it would get the input date and then retrieve back the start and end date for the weekly and the daily. As you can see, we could also show the requests for changing the old device ID to the new device ID, depending on if we want to use a new particle sensor. And that's pretty much it. Thank you. Stop.
Hi, I'm Jason White. I'm the backend program for here. I'm going to really briefly talk about the chatbot. I used imported container from OpenWeb UI. As you can see, this is something that just runs off of the Docker that you can run yourself, but you have to have an extension from ngrok. And I'll have a separate account of fake data that the TA can look at through on the website to test that out. Now, the chatbot over here, this is there's a HTML that Mohammed improved, but the big thing to get into this code, and what's important to point out is, besides this is what you use for the actual ngrok, and this is the URL that you use for local on the EC2. It's set up appropriately, but the part down here to point out is in the messages, we're in the get daily message that is ran to get the most recent message from that day. So you have to have, measurements from that day. So you have to have measurements actually of that day, because it's the best you can do with a model to be ran lightweight. Is I have this message here that is, please use my heart monitor data to inform your response. Response succinctly in less than 10 sentences. And the model I'm using is Gemma 3-1B. Okay. Now, do a little speed run. Things that are of the most importance is through here. This right here is what you have to use so we can not have HTTP upgrading to that. I had to do a certification. This is my rate limiter. That way you have some form of security. Here is the proxy route posting that I had to do to get ngrok to work and the cores to approve of it. And the most important part is that I have to have two listening devices, one for the browser, because it has to not automatically do upgrading, so I have to use HTTPS, but then also for HTTP, because the webhook, that's what that wants. Here's my auth. This right here is the JWT token handler that confirms it whenever a user is in the browser. But I'm going to try to make this one. Okay, I'm going to make this a little more snappy, but I'm just going to show you that this is connected into testing onto the actual EC2 server. So I won't really show up with the website, but let me just show you on the endpoints that I'm working. This right here is the console for the actual EC2, and this is for the Mongosh that shows the database. I'll show DBS that you actually have in HeartTrack, and I'll show things get added on. Right now in here, I'll create a user, and you can see on here that this gets added. And then I go down over here and I log in. And see right here, success, JWT generated, and we can see the work done. And right in over here, I'm going to give some, some fake measurements. As you can see, can't go too fast because my rate limiting for security will kick me out, but I'll just give these a couple more clicks and I'll show you, just some of the testing that I've done, and then I'll show you how this looks on here. Is that hopefully this guy today, I can get, a daily view values, and I'll show it on here where I'm testing those endpoints. And then I can also do a weekly view, where it also gets some values, and I can show my endpoints over here of what it brings up. Now, let's say in here, just to show that I'm going to, let me change the password first, okay? So on here, let me just, let's see, users, let me do this one first. Okay. As you can see, I have, an example user, and here's my pass hash, and you'll see that'll change when I change the password to my new password. Okay, here, boom, you can see this change in here, and I'm going to bring this up again into the database, and you're going to see that the hash is different, the endings are different over here, and therefore it's a new value. So let me just go ahead and change it back really quick. Okay, now again, hash values are different, but I changed it back, and you'll see it's a different hash value, being that's just how hash values work. Now here is where, let me bring up and show you the measurements, and I'll show you on here on how all the values of the measurements are still tied in. So you can see in here, here's our device ID that we have here. So I am going to change the ID right here. Boom. Old device, and I have test device 123. That's a new device ID I put in here. So it updated on the counts on the left, the outputs I have, and then also for here, you can see that it assigned, the new test ID. That way the user still keeps them all. Yep. And yeah, yep. And I will, and for the TA to test the, to show, we already showed the AI on the front end programming, but I'll have a separate account that'll be listed in the README to show the AI. And all right, and next we will show with the actual measurements from the Photon 2 device.
Hello, my name is Jesse, and I am the hardware developer for this section of HeartBeat. As of here, we'll be going over the main sections of the code. We have in our main file the receive data and web handler, which both handle the webhook responses and uploads, so I know if they properly run or not, and if they throw an error. The setup loop focuses on controlling the Wi-Fi and internet connection, along with initializing all of the project subdirectories, including the MAX 30102 blood sensor and the LCD that I use along with it. My main code uses a state machine that uses Boolean manipulation and a lot of calculating time functions in order to shift in between each state at a given interval as set from the user on the web page. The intervals are defaulted to 6 a.m. to 10 p.m. for the runtime of the particle photon 2, and has a blood sensing rate of every 30 minutes. After each state is triggered, it constantly checks timeframes and gets the data, and depending on if certain flags are set while in these timeframes, it will move into specific states to allow for the next upcoming files to communicate with either the server or to stay in an offline state to maintain its data. Let's go over the first file, which is the data handler. This is the initialization of the subdirectories for the particle photon 2. We have our LCD and particle sensor that are handled here, both split into nice, easy categories to look into. These are the Boolean manipulation that will only be triggered once depending on what state the particle photon is in. This is my print server response, which allows me to print on the LCD if the server is having any sort of error. A missed measurement also. If you miss your measurement, it will flash purple for about 10 seconds, letting you know that you will have to wait until the next config integer that you set up to take another measurement. This is the main file, the get data function. This controls the entire blood sensor, in which it uses a algorithm in order to calculate your SpO2 and heart rate, and depending on if it's valid or not, it would add to a count. This count can and could be changed if you want it to be more accurate, and as of now it is set up for 5 for the demo here. And then I have a reset function that monitors the data and resets it whenever it comes back into the function. I have 3 time frame check functions. The check time frame is whenever you set up the particle photon 2 to determine if it should go into sleep mode or if 5 minutes have passed. The calculate time till awake is the time function that handles the amount of seconds the particle photon should be in sleep mode. And the test time 2 is a Boolean function that is used in the get data to handle if you waited 5 minutes or not. Then I have an upload handler, a CPP file, that properly handles the uploading of the data to the server. If the server responds properly, it will flash green, in which it will tell the user if the data was received on their end or not, in which they will be able to see on their end if they have a heart rate. Hold on a second. As of now, it was stored and it was sent through the particle photon, in which it sends a device, and the message responded with a positive note. And now we can go all the way around to see if the server responded kindly or not.
Where is it?
It's right there.
It's right there.
This is how the server communicates with
At the bottom.
Yep,
the...
you see it. Measurement saved.
And that's it. Thank you. Goodbye.
And well, you can, one more thing, actually, if you want. We can show that it's in the, just to show it specifically, it is in the database. As you can see, the measurements are stored in the database.
Great. Thank you, everybody.
We're logged in, and the token is compared. Here's the device. Here are the schemas. The schema for the device that has the actual serial number. Here's the config, where we have our schedule that the users can set and the device can get. And here's our measurements, where the measurements are actually stored and that the user sends. And here is the user, where we have the username password. All right, here's the auth, the posts in here. The biggest thing to point out in the auth right here is we have our register, we have our encrypted salt hash. Here's the login, where when somebody logs in, it compares the passwords appropriately with the salted hashes, and also creates a JWT payload that it gets sent to them, so the browser can store. Here's the logout, where, the logout is just on the browser side, but I send them a status code. All files have appropriate status and error codes. Here's the change password, where it is done appropriately. And also the device is here. The device is right over here, where we actually register the device. That gets handled in creating in the account. The important part is that is the actual serial number for the Photon 2. Here is the device config, where the UI can fetch the schedule. Here is the where the web app saves the schedule. The device daily measure. weekly measuring point, and also the getting the devices. Here is the measurements that are posted for the device, for the Photon 2 device. You know, the measurement route also specifically has it where JWT is not interfering, because that is not an issue that the Photon 2 device needs to deal with. That's the important part for that part. And this right here is where the device can get the config, and also a measurements for regular measurements for the JWT for the user.
That's it.
That is all I have on here, and then I'm going to get to running the actual device with Jesse and showing it on the EC2.
Great.
Hi, I'm just adding on a special video for the chat bot. As you can see, this is the EC2 console right here, and this right here is our website that goes to the chat bot. I asked it here, how's my heart health, and it gives an answer, and as you can see, it goes right over through here, and I have my upstream status where I have my model, the GIB, the message, yep, and where it kind of, you know, tells me what's going on. This is to show and prove that this chatbot is in here, and I'll just ask you something further. Is my heart rate good, or is my heart rate within range? Should I be worried? See, it just added, you know, I got an output over here, and then it responded. So this is to show proof right here that I have it hooked up and it is responding with the EC2 server. Thank you.